Welcome to the lecture on engineering statistics and linear algebra. So in this lecture, I am going to discuss briefly about what is meant by eigenvalues and eigenvectors and how to find eigenvalues and eigenvectors. So first we will learn what is meant by eigenvalues and eigenvectors. So first consider a square matrix A over a field F. The matrix A minus lambda I. So in this A minus lambda I, where I is called unit matrix as same order. I mean that is if A is n cross n matrix and I should be a n cross n matrix only. And here this lambda is called indeterminate, is called characteristic matrix of A. So this is called the characteristic matrix of the given matrix A. So now if A is a square matrix of order n cross n, then the determinant of A minus lambda I is a non-zero polynomial of degree n in terms of lambda. So this polynomial will be called as an characteristic polynomial of the matrix A. So now the equation determinant A minus lambda is equal to 0. So this condition is called characteristic equation of A or the eigen equation of A. So it can be very useful in finding the eigenvalues. So now the roots of this characteristic equation will be called as an eigenvalues or the characteristic roots of the given matrix A, and we can find the eigenvectors also corresponding to these eigenvalues from the equation Ax is equal to lambda x, where x is a column matrix, which can be useful in finding the eigenvectors. Or we can use this formula also, the matrix A minus lambda I into x is equal to 0. So these two can be useful in solving the eigenvectors. Some properties based on the eigenvalues and eigenvectors. If a matrix A is real, then its eigenvalues are real or complex conjugate pairs. So property number 2, sum of the diagonal entries of A will be equal to the sum of the eigenvalues. So the diagonal adding all the diagonal elements, it will be equal to the adding all the eigenvalues. Third property, the determinant of A will be equal to the product of the eigenvalue. So now property number 4, the matrix A and A transpose will have the same eigenvalue. So if I interchange the number rows and columns in the A matrix, then the eigenvalues of the A matrix will be equal to the eigenvalues of the A transpose matrix. If all the eigenvalues are non-zero, then the determinant A will not be equal to 0. That is, A is a non-singular matrix. Suppose if the determinant A will be equal to 0, then at least one eigenvalue must be 0 in the given matrix. So the matrix inverse exists if and only if 0 is not an eigenvalue of the matrix. So if 0 is the eigenvalue of the matrix, so we can't find the value of the A inverse. For the matrix A with a scalar multiplication, then Ka will be the eigenvalues of K lambda. So the for example, I'm multiplying some constant K for the given matrix A, then the value K lambda I is the eigenvalue of the given K matrix now. The matrix A power m has the eigenvalue lambda power m. And last property, the diagonal entries of a diagonal matrix or upper triangular matrix or lower triangular matrix are the eigenvalues. Note, to find the eigenvalues, we can use the following equation also. The first equation is, if A is a 2 cross 2 matrix, then we have to use lambda square minus summation d into lambda plus determinant A is equal to 0. For 3 cross 3 matrix, we have to use lambda cube minus summation d lambda square plus summation md lambda minus determinant A is equal to 0. Example, find the eigenvalues and eigenvectors of the matrix A is equal to 3, 1, 4, 0, 2, 6, 0, 0, 5. So the given and upper triangular matrix they have given. So we have to find the eigenvalues and eigenvector for this matrix. So we'll see how to find that. First consider the matrix A is equal to 3, 1, 4, 0, 2, 6, 0, 0, 5. Since it is a 3 cross 3 matrix, take the equation lambda cube minus summation d lambda square plus summation md lambda minus determinant A is equal to 0. Find all the values now. First I'm going to find summation d. So summation d in the sense adding all the diagonal entries. So that is 3 plus 2 plus 5. So answer will be 10. Summation md in the sense adding all the minor diagonals for 3. I'll be having the minor 2605. For the minor 2, the value will be 3405. For the minor 5, for the entry 5, the minor will be 3102. So on simplifying this, the answer will be 31. Next, determinant A. On expanding this one, the answer will be 30. We'll get it. So now I'm going to incorporate all the values in the equation. So I will be getting the equation like lambda cube minus 10 lambda square plus 31 lambda minus 30 is equal to 0. I'm going to find the roots by using synthetic division method. So take 1 minus 10, 31 minus 30. So now I have to choose a root like that. So the last entry must be 0. So if I take 2 here, I'm getting the last entry as 0. So take the entry 0 here. Adding this one, I'll be getting 1. By multiplying 2 into 1, I'll be getting 2. So by adding this, I'll be getting minus 8 here. Again, by multiplying minus 8 with 2, I'll be getting minus 16. By adding this, I'll be getting 15. Again, by multiplying these two, I'll be getting 30. So it becomes 0. So once it is 0, the first root will be, we can consider, that is lambda is equal to 2. The next equation is lambda square minus 8 lambda plus 15. On simplifying this further, we'll be having the equation like lambda square minus 5 lambda minus 3 lambda plus 15 is equal to 0. So on finding the roots for this equation, so it will be equal to lambda minus 3, lambda minus 5 is equal to 0. The roots are lambda is equal to 2, 3, 5 and all are non-repeated eigenvalues here. So now for this eigenvalues, I'm going to estimate the eigenvectors. The first thing is we have to consider the matrix to find the eigenvectors. Consider the matrix A minus lambda I into x is equal to 0. Take the matrix A here minus lambda into, take the identity matrix. Since A is 3 cross 3, take I also 3 cross 3 only, and x is a column matrix which can be useful in finding eigenvectors, and 0 is a 0 matrix here. So on subtracting this one, I got 3 minus lambda 1 4, 0 2 minus lambda 6, 0 0 5 minus lambda into xyz is equal to 0 matrix. So on multiplying this equation, we'll be having 3 minus lambda into x plus y plus 4z is equal to 0, 2 minus lambda into y plus 6z is equal to 0, 5 minus lambda into z is equal to 0. Call this one as equation number 1. So now I'm going to find the eigenvectors for the obtained eigenvalues. The first case, I'm going to replace the first eigenvalue. Put lambda is equal to 2 in the equation number 1. So if I replace lambda is equal to 2, the equation will be x plus y plus 4z is equal to 0, 0x plus 0y plus 6z is equal to 0, 0,6 plus 0y plus 3z is equal to 0. So now I am going to use the cross ratio method. To use the cross ratio method, take 2 equations only. So out of 3, I'm choosing only 2 equations and taking 2 different equations. Okay, so I'm taking the first 2 equations here. That is x plus y plus 4z is equal to 0 and 0 plus 0y plus 6z is equal to 0. So for the x1, so skip complete x column, take the minor of the remaining elements, that is 1 4 0 6. Next is take here, always take start with a minus y. So skip complete y values here, take our remaining the elements, that is 1 4 0 6 here. Next is z. So for z, skip complete z column, take the elements of xy, that is 1 1 0 0. So on simplify this, I'll be getting the answer x by 6 minus 1 by 6 z by 0. So I can take 6 common factor. So it will be equal to x by 1, y by minus 1, z by 0, I will get it. So hence the corresponding eigenvector of the eigenvalue lambda is equal to 2 is 1 minus 1 2. Next is, I am going to replace lambda is equal to 3. So in the same equation number 1, I am putting lambda is equal to 3. If I replace lambda is equal to 3, the values will be 0x plus y plus 4z is equal to 0 I am getting. Again 0x minus y plus 6z is equal to 0. 0x plus 0y plus 2z is equal to 0. So same thing also, to use the cross ratio method, take any 2 different equations, not same one. So for x1, so skip complete x values, take 1 4 minus 1 6. Again minus y divided by, so skip complete y values, that is 0 4 0 6, I will take it here. And for z, skip complete z column, I will be taking 0 1 0 minus 1. So on simplifying this, I'll be getting the value x by 10 minus 1 by 0 z by 0. I'm taking 10 outside, the answer will be x by 1 y by 0 z by 0. Then the corresponding eigenvector will be, for lambda is equal to 3, is x2 is equal to 1 0 0. Last case, for third eigenvector, that is for lambda is equal to 5 in the equation number 1. So replacing lambda is equal to 5 in equation number 1, the equation will be minus 2x plus 5 plus 4z is equal to 0, 0x minus 3y plus 6z is equal to 0, 0x plus 0y plus 0z is equal to 0. So taking here the same thing only by using cross ratio method, I'm taking only first 2 equations. So I'll be getting x by 18, y by 12, z by 6. So since your common factor is 6, I can take 6 common factor. Remaining will be x by 3, y by 2, z by 1. So hence the corresponding eigenvector for the given matrix will be lambda is equal x3 is equal to 3 2 1. So in this way we have to find the eigenvalues and eigenvectors. Thank you.